Okay, welcome back, fifth graders. We're at Unit 7, Lesson 17, and in this slide we're going to decide what we need to do with the remainder. Again, just some vocabulary review here. We call the answer to a long division is called the quotient. The number we're dividing by is called the divisor. The number we're divided into, in this case 487, is called the dividend. And the easiest one of all of them is the remainder. Sometimes the remainder factors into the answer. Sometimes the remainder is the answer. Sometimes they want the remainder as a fraction or as a decimal. We're going to see that kind of stuff throughout the lesson, is what means, or what do we do with that leftover.
Alright, so as you saw on the previous slide, this lesson is all about interpreting or figuring out our remainder. So in this case, we have a problem where sometimes you might ignore the remainder. Our question says, the gift wrapping department of a store has a roll of ribbon 1,780 inches long. It takes 1 yard of ribbon, which is 36 inches, to wrap each gift. How many gifts can be wrapped? So this is a question we're going to answer here. Well, if I have 1,700, oops, I'm going to write that where I have a little more room. So if I have 1,780 inches of ribbon in all, and I know that I'm going to use 36 inches to wrap each gift, I can divide to figure out how many total gifts I'll be able to get. So, first thing I ask myself, does 36 go into 1? Nope, so I put up a 0. Does 36 go into 17? Again, no, so I put up a 0. I'm going to use my front number estimation to figure out what number I should multiply with first. So I know 3 can get close to 17 by multiplying it by 5. 3 times 5 is 15. So I'm going to try 36 times 5 to see if that gets me close to 178. 5 times 6 is 30, carry the 3. 5 times 3 is 15, plus 3, 180. Oh shoot, I went a little bit over. So that means I'm going to have to use 36 times 4. So 4 times 6 is 24, carry the 2. 4 times 3 is 12, plus 2 is 14. Alright, so now I know that's the closest I get because 5 brings us overboard. So I'll put a 4 up and then write 144 here. So now I subtract. 8 minus 4 is 4. 7 minus 4 is 3. Next, I bring down my 0. Okay? So now I think of 3 and 34. I know 3 times 8 is 32. So I'm going to try 36 times 8. Okay, 8 times 6 is 48. Carry the 4. 8 times 3 is 24. Plus 4 is 28. Now I'm wondering if I can get closer. So I'm going to try 36 times 9 just to be safe. 9 times 6 is 54. 9 times 3 is 27. Plus 5 is 32. Okay, so yes, I could get closer. So I'm glad that I checked. So now what I'm going to do is put my 9 up and subtract 324. Okay. When I subtract that, I'll end up borrowing, and 10 minus 4 would give me, I'll write my answer over here, 6. 3 minus 2 is 1, and 3 minus 3 is 0. So I have 16 as my remainder. Okay, so the reason that's my remainder is because I didn't have any more numbers to bring down. So I'm only going to use my final quotient of 49 gifts that can be wrapped, because my remainder of 16 would stand for how many inches of the ribbon is left. And remember, it takes a full yard or 36 inches to wrap one gift. So if I only have 16 inches left, I will not be able to wrap any more. So in this case, we ignore the remainder and just answer with 49 gifts.
Alright, in this slide you're going to see sometimes we round up to the next whole number. It says there's 247 people traveling to the basketball tournament by bus this year. Each bus holds 52 people. How many buses will we need? Now, obviously we're going to solve this problem with 247 divided by 52. But already I can tell you this is a perfect example. You know what? If we get an answer and then there's a remainder with any leftover, we need a whole nother bus for, let's say there's 3 people left over. So we're gonna have to add 1 to our answer, to our quotient when we solve this. Okay, I'm gonna use this technique looking at this first number 5, and I'm looking at going into 24. I know 5 will go into 24 times, so I'm going to use that. I'm going to use 52 times 4, which is 208. Okay, that should be big enough. Whoops, 208. 208. All right, when we subtract, so that's 4 times. When we subtract, we are going to get 939. Okay, so that's a number that reduces to a 3 there. That's how I get 39. Now that's smaller than my divisor, so that's okay. Now, how many buses we need? Again, it looks like our answer is 4, but we have 39 people that do not fit. So we're going to need a 5th bus for that. So in this case, we had to round up because the problem didn't say like how many packages did we have or anything. It asked for how many buses, and we have to take all the people. So even if there was only 2 left over, we'd have to take a whole nother bus for that. So the answer would be 5 buses.
Alright, boys and girls, now we have an example where sometimes we may use the remainder to form a fraction. So number 3 says the 28 students in Mrs. Colby's class will share 98 slices of pizza equally at the class picnic. How many slices will each student get? Okay, it says look at the division shown here. Explain how to get the fraction after you find the remainder. So let's do the division first. So I know that there's 98 total slices, and there's 28 students that are sharing it. So I'm going to have to divide those 98 slices between 28 students. So I'm taking 98 divided by 28. So here I'm going to think of this as the rounded number 30. Front number there is 3, and I know that 3 would go into 9 or 98 probably about 3 times, because 3 times 3 would give me 9. But first what I'm going to do is I know 28 will not go into 9, so 28 will go into 98. And I estimated that it'll be about 3 times. So let's check. 28 times 3. 3 times 8 is 24. Carry my 2. 3 times 2 is 6. Plus 2 is 8. 84. Yep, and that's going to be as close as I can get. So I'm going to put 3 up here. And now I'm going to subtract 84. 8 minus 4 is 4. 9 minus 8 is 1. So in this case, my remainder now is 14. I don't have any more numbers to bring down. So I know that this first part of my quotient, 3, is going to be 3 full slices of pizza. Now, I'm not going to say to a student, all right, you get 3 and remainder 14 slices. Does that make any sense? No. So what I can do is take my remainder, 14, and put it over my divisor to make a fraction, 14/28. Now, some of you might already have noticed that I can simplify this fraction. I can divide both of these by 7. So that when I do that, I get 2/4. Well, now I already know that 2/4 can be further simplified to equal 1/2. You might have noticed, too, that 14 is half of 28. So we simplify the fraction 1/2. Now, that makes a lot more sense. If I told a student you get 3.5 slices of pizza, that's a lot more informative to a student than remainder something. So in this case, we took our remainder, 14, put it over our divisor, 28, simplified to get a fraction 1/2. So I would tell that each student could have 3.5 slices.
Okay, sometimes you need to find the decimal number instead of the remainder. Suppose 16 friends earned $348 at a car wash, and they wanted to divide the money equally. To find out how much each person will get, one of the friends divided as shown here. each friend will get 2175. Well, we're gonna check their math. I assume that it's right, but we're gonna divide. Now there's something again. The remainder wouldn't go to one person. You'd want to split it up amongst everybody. So I can use this to help. We know that 16 goes into 34 twice. Actually, 16 times 2 is 32. When we subtract, I would get 2, bring down my 8. 16 goes into 28 only once, which is 16. When I subtract, I get 12. Now remember, we could do this one or two ways. We could write 21 and 12/16, and then we could take our calculator and divide 12 by 16, and we would get a fraction. Actually, we can reduce this fraction. We should know that we can divide 12 and 16 both by 4, which would give us 3/4, and we do know that 3/4 equals 0.75. So again, with what we learn in fractions, you can come up with your decimal that way. Or, remember, we can add a decimal, put a decimal in our answer, and add a 0, and we keep dividing. So 16 I know is going to be 7. 16 goes into 127 times. 42, 7, that's 112. When I subtract, I'm going to get 8. Okay, and again I'm going to bring down another 0 after the decimal. I can add as many zeros as I want and keep dividing. So let's try 16 times 5, which is 80. Okay, so that is the correct answer, 2175. Again, what I wanted to point out is you can add a decimal and add zeros and find that, or you could have put it into a fraction and reduce the fraction and then maybe get it into the lowest terms. Like if we get 0.5, we know that equals 50. If we get 1/4, we know that's 0.25. Okay, there's many of those fractions we already know how to change it to a decimal. Again, I wouldn't mind students using a calculator and taking 12 divided by 16, and you would have got 0.75.
Alright, ladies and gents, here we have yet another example of interpreting or figuring out our remainder. In this case, sometimes the remainder is the actual answer to our problem. So let's take a look at number 5. This says a bagel shop has 138 bagels to be packed into boxes of 12 to be sold. The extra bagels are for the workers. How many bagels will the workers get? Okay, so we're going to figure out why the remainder ends up being the answer. So first of all, I know that the shop has 138 bagels in all, and they're supposed to be packed into boxes of 12. So that means if I take my 138 bagels and divide by 12, I'll figure out how many boxes I get. Then I see that the extra bagels are for the workers. Okay, so that'll come into play when I find my remainder. So first I look at this, does 12 go into 1? Nope, 0 times. Does 12 go into 13? It does, once. 12 times 1 is 12. Now I subtract. 3 minus 2 is 1, 1 minus 1 is 0. Now I bring down the bring down the 8 to create 18. 12 goes into 18 again once. So I know 12 times 1 is 12. Now I subtract. 8 minus 2 is 6. 1 minus 1 is 0. I have no more numbers to bring down, so that is my remainder, 6. Now, let's look at the question again. I know that it has to be packed into boxes of 12. Here I found that that would be 11 boxes of bagels that are being sold. But the question asks us, how many bagels will the workers get? Remember that only the extra bagels go to the workers. So they're not going to get any of the bagels in the boxes, but they could eat the extra bagels. Here's where our remainder comes into play. My remainder are the 6 extra bagels that don't get packed into boxes. So I would say that the workers will get 6 bagels. So in this case, because we're looking at the extra information, The remainder was our answer to this problem.
Okay, we have two-story problems where we're going to use this and again decide what to do with the remainder. At the Cactus Flower Cafe, all the tips are divided equally among the waiters. Last night, 16 waiters took in $1,108. How much did each waiter get? So I'm going to divide 1,108 divided by 16. Okay, might have to do a little bit of thinking here. This is kind of a tough one. I'm gonna choose 8. Let's go 16 times 8 and see what I get. 48. Carry the 4. Oh, that's still too big. Just by a little bit. That's 128. Okay, 16 less than that. Oh, it's still gonna be too big. So let's go 16 times 6. 36, carry the 3, 6, 9, 96. Okay, borrow, make that a 0. That's 14. Yep, that one, so 6 was the right number. Okay, that's right. This problem may help me pick my next number, so it's really not wasted time. So I subtract, I get 148. Alright, well, we know that I can take another one, so it's got to be 16 times 9. 54, carry the 5, 9, 144. Okay, subtract, we get 4. Again, don't forget to put your 9 up. Now, just like I showed you on the slide before, I'm going to add a decimal and a 0. So now I have 40. 16 goes into 40. Let's see, twice. Okay, so I put my decimal point up 2 times. I'm going to transfer that 40 right here so you can see twice times 16 is 32, and I get 8. And it's kind of the same numbers I had before. 8 times 5, or 16 times 5, when I bring down my 0, would give me 80. Yes, it does. So each person would bring home a tip of $69.25. Now, this worked out nice. There might be a possible way that they have a tip where it doesn't break into equal amounts. So maybe what they do is they have a tip jar and they'll throw that into the next night. Alright, let me get rid of some of that, and we will go on to the next problem. The next problem says a gardener needs to move 2,150 pounds of dirt. He can carry 98 pounds in his wheelbarrow. How many trips will he need to make with the wheelbarrow? Now, here's one with the remainder on this problem. If he has some left over, even though it's not full, he'll still have to make an extra trip. So the remainder is going to factor into my answer because he has to move all the dirt. So now I got that finally. We can take 2,150 divided by 98. Now again, don't forget about our estimating. If this was 100, okay, and this is 2,000, about, we know it's going to be about 20 trips. So I'm going to keep that in mind and see how close I am to that. So first of all, 98 into 215, we know we'll go twice because 2 times 100 is 200. That's going to get me close. 98 times 2 is 16, 196. Go ahead and subtract. Is 9. Got to borrow again. Is 1, 19. Okay, bring down the 0. Now, see how this helped me? That's 196. So actually, I can only get a 1 out of there. Okay, that's 98. When we subtract, actually I'm going to subtract from the 19, make it 18. So save me a step. get 2, 92. Okay, so in 21 trips, there'll be 92 pounds of dirt left. So that means he's going to, with that remainder, he's going to have to make one more trip. So a total of 22 trips. Keep in mind that last trip the wheelbarrow won't be quite full because he can carry 98 pounds at a time, but he will still have to make that extra trip. There's where the remainder changes your answer. Look at my quick estimation was 20. The answer is 22. I think we have a reasonable answer.
Alright, boys and girls, I have a few more examples to show you where we'll interpret the remainder or figure out the remainder. Number 8 says, Mia must work 133 hours during the month of May. There are 21 working days in May this year. How many hours per day will Mia work if she works the same number of hours each day? So, I know that Mia has to work a total of 133 hours, and she has to split that among 21 days in May. So that means I have to divide 133 by 21 to figure out how many hours she'll be working in each day. So if I first look at this, 21 does not go into 1, so I'll put up a 0. 21 does not go into 13, so now I have to figure out how many times 21 goes into 133. So I'm going to look at my front number estimation. I have 2 and 13. 2 times 6 would get me close to 13. So I'm going to try 21 times 6. 6 times 1 is 6. 6 times 2 is 12. Perfect. That does get me as close as I can. So I'm going to put up my 6 and now subtract 126. So I can't do 3 minus 6, so I have to borrow. This becomes 13 minus 6, which is 7. 2 minus 2, 0. 1 minus 1, 0. So I have no more numbers to bring down, so this is my remainder now. But the only problem is I wouldn't tell Mia that you have to work 6 hours, remainder 7. That doesn't make any sense. So what if I put it in a fraction? So what that means is I'm going to have to take that remainder, 7, and put it over our divisor, 21. So 7 over 21. Now I have to think, okay, can I simplify this? And yes, I can divide both by 7. When I do that, 7 divided by 7 gives me 1, and 21 divided by 7 gives me 3. So this would be a much more easier number. I could tell Mia that she has to work 6 and 1/3 hours each day. 1/3 is a much more manageable fraction of time. For example, 1/3 of an hour, 1/3 of 60 minutes would be 20 minutes. So she has to work 6 hours and 20 minutes each day. That's more manageable and understandable time. So in that case, we interpreted the remainder by using it as a fraction. Let's look at number 9. This says, colored markers cost 78 cents each. Pablo has $8.63 in his pocket. How many colored markers can Pablo buy? Okay, so the first thing I'm going to need to look at is taking his money amount, $8.63, that's his total, and he's dividing that by how much each colored marker costs. Now keep in mind this says 78 cents. That means we have a decimal. Now we haven't talked about this very much in detail, so what I'm going to show you here is a new concept, so please watch carefully. Okay, when you divide by a decimal, so when your divisor is a decimal, you have to first change it to a regular number. Then you can divide. So the way we do this is we will take our decimal here and count. That's 1, 2 to the right to make it our normal number, 78. So in that case, if I do it to the divisor, I have to do it to the dividend, which in this case is 8.63. So I have to take that and move it 1, 2 to the right as well. Same treatment. So now my new dividend is 863. Okay? So again, that was a new concept, something new for you, but we need to do that in order to be able to divide here. So again, I took $8.63, that's how much money Pablo has, and I'm dividing that by 78 cents because that's how much each colored marker costs. We want to know how many markers he can buy. So first, can 78 go into 8? Nope, put up a 0. Can 78 go into 86? Yes, it can go in one time. 78 times 1 is 78, so I subtract that. Going to have to borrow here. So now I have 16 minus 8, which is 8. 7 minus 7, which is 0. And now I bring down my 3. Okay? Here I can see that 78 goes into 83. Again, just one time. So 78 times 1, I subtract 78. Again, I have to borrow, so then I have 13 minus 8, which gives me 5. Now, that's going to be my remainder, because keep in mind, my decimal is now at the end here. So I have the number 11, and then remainder 5. Now I have to think to myself and figure out, okay, do I need the remainder, or do I need to change it into a decimal or a fraction? The question says, how many colored markers can Pablo buy? Well, I wouldn't tell Pablo you can buy 11 markers, remainder 5. He can only buy 11 full markers, so he's going to have leftover cash or leftover cents. So in this case, my answer for this problem is 11 markers. I actually ignore the remainder because we can't buy part of a marker. We're just going to buy 11 full markers. And that's our final answer. So in this case, we ignored a remainder.
Okay, that was a good lesson on how to use a remainder and how to change it to a decimal, fraction, etc. It ends up being important in a lot of problems, so it's good to know what to do with that leftover stuff. Complete your ticket. We're almost done with long division, so hang in there, and we'll see you tomorrow.